So you're going to learn about exponential growth and exponential decay. We all hope that we exponentially grow our money, where it starts off slow and then boom, rises up. Okay? So that would be this example. This would be an example of growth. Okay? Because you're going slowly and slowly and then boom, it increases. There's also something called exponential decay. You could also lose your money really, really quickly. You could start off with a lot of money and then you lose it. But something I need you to get is that even though it looks like it's touching that line, it never actually does. If you invested money in the market and you lost all your money, you could still have a fraction of a penny. So if you think about it, that's when this would be an asymptote right here, because you'd never actually hit the zero. So this would be an asymptote of y equals 0. Okay? This is technically an asymptote as well. If you start off with $0, you can't grow it. But if you even have a penny, you have the possibility of growth. Okay? So the thing that I really want you to focus on is the difference between this and this. And this is the part that is the most confusing to people. So when they say between 0 and 1 and greater than 1, what they're talking about is a percent. Between 0 and 100% is decay, and this means greater than 100%. If you started off with $1 and it grew, that means you're having more than 100%. If you start off with $100 and you lose money, you only have a certain percentage of your money left. So let me give you an example. Let's say I started off with $300 and I gain, I get 4% growth, exponential growth. I can't spell growth, okay? Or 4% decay. So I lose my money at a 4% rate. There's two different ways that you would write this equation. This one would be y equals 300 is the start to the x. Now the issue is this growth or this decay. If you grow your $300, you have $300 plus another 4%. So you have your $300 and 4%. When you do a percent, you can't write it as a percent, you write it as a decimal. 1, 2. If you decay by 4%, you don't have more than $300, you have less than $300. So in a sense, you take your 100%, but you're taking out 4%. So now you're left with 96% of your money. So you're losing 4%. So you would write that as 0.96. Let me do another example, okay? I have $512, okay? If I have a growth of 3.1% versus a decay of 3.1%, my equation is y equals 512. Y equals 512. The percentage of growth or decay goes in the parentheses to the x. If I grow my money, I'm going to have more than $512 by an additional 3.1%. Okay? So it would be 1.031. Because what I'm doing is I'm going like this, moving it over twice, and I'm going 1 plus 0.031. Or 100% plus 3.1% is 103.1%. If I decay, I'm going to have less than $512. So I'm really going 100%, I do my percents backwards, minus 3.1%, which is 96.9%, or 0.969%, or as a decimal, okay? Just so you can kind of understand the differences. So that's why it's never negative in here. You end up with negative money when you lose money and lose money and lose money. This is decay. Decay is anything between 0 and 1. 0.96 is between 0 and 1. But growth is everything greater than 1. Greater than 100%, that's the growth. So in this one, I just want you to tell me if it's growth or decay and justify it. So I look here, it's decay because 0.8 is between 0 and 1. Yes, this question is on your quiz. Yes, don't get it wrong. This is growth because 1.2 is greater than 1. Okay. I started with $30 and I'm losing money at a rate of 20% every month. Okay, that's what that means. This is I start with $5 and I grow my money by 20%. Let's turn the page. Let's actually do some problems now. Oh, all right. So now that we know that, we're going to do these examples. So if you look, take a second, read through it, figure out what's the start, what's the growth. So when you read this problem, there's certain things that stand out. I noticed that 12,000 is my start, and it says write a function, so let me write it as f of x equals 12. And when we write a function, we don't put the comma. You can put the comma, but it's just kind of ugly, okay? Now, since it says it's increasing by 14%, we know it's growth. So that means we're taking 100% plus 14%, which is 114%. Or some of you know it's 1 plus 0.14, which is 1.14. Oops. And that is letter A done. Graphing it. Okay, so if I'm going to graph this thing, it's related to real life. So even if I put X and Y, I have to talk about what that's going to be. X, most of the time, is time. So let's see, they're talking about year. And then talking about how much something is worth. So we're talking about money in dollars. Okay. Year happens 1, 2, 3, 4, 5, 6. But then, let's see, they're going to gain money. So it's 12,000. So I kind of feel like if we went by fives, we might be okay. So in order to graph this thing, let's see, I'm going to start at 12,000. And honestly, I'm happy with you just going like this right now to get to see that it's exponential. Okay. All right, letter C, figure out the value when it's going to be 60,000. So 60, 1, 2, 3 equals 12,000, 1.14 to the x. So for now, you kind of know how to solve, but only halfway. So you can divide by 12,000, and you get 5 equals 1.14 to the x. You don't know how to use logarithms yet, so what you're going to have to do is just guess. 1.14 to the 5th. No, that's not 5. 1.14 to the 20th. That's 13, too big. 1.14 to the 15th. Oops, sorry about that. To the 15th. 7, I'm getting closer. 1.14 to the 12th. 4.8, so let me just make sure. 1.14 to the 13th. That's too big. So it's going to take about, well, we have to make it happen first, don't we? So it's going to be about 13 years, a little bit before then, but it's going to be about 13 years. Okay, let's look at the next one. The value of a truck decreases. All right, function. Sorry, you can't see any of that. So read the problem. 28 grand, 1, 2, 3. This time it's decreasing, okay? So instead of having 100%, you have 100% take away 9.5%, or 1 minus 0.95. Whatever you want works for me, but you get 0.905 to the x. So if I went 100 minus 9.5, I get 90.5, 1, 2. If I go 1 minus 0.095, I get the same exact thing. Okay, so that's letter A. Letter C, graphing it, time is year. X, 1, 2, 3, 4, 5. It starts at 28 grand, but then goes down. So I want to feel like 28 should be kind of up here. That way I can get a good picture. So I feel like if I went by fives, it might be too little. So let's go fours. 4, 8, 12, 16, 20. Wow, that's still a little bit small, but it's a little bit smaller. Start at 28 grand, and we know it goes down. Now, it's never going to hit 0 because it will be worth something to somebody. Letter C, when is it going to be worth 5 grand? Solve, divide by 28 grand. Okay, so 5, 1, 2, 3, divided by 20, 28, 1, 2, sorry about that. I get a decimal, 0.17. For now, that's fine, okay? And then it equals 0.905 to the x. And now we're playing the guessing game. And you need to practice guessing this, okay? Don't just watch me and wait for me to get the answer. You need to practice it on your calculator so you know how to do it. 0.905 to the 10th. 0.36, okay, and that's 0.178. 0.905 to the 15th. 0.22, we're getting closer. We're getting closer because in a decimal it's the reverse. 0.905 to the 18th. I get 0.16. Okay, so there's 0.1. I feel like I got to write this one down. So 0.16 was the 18. And so now I'm going to say 0.905 to the 19th. That's too small. 0.905 to the 17th. That's a little bit too big. So it looks like that by the 18th year, it'll be worth about $5,000. Okay? And those are the kind of things we think about when we're dealing with investments and how long we buy things. And you know, those people like keep trading cards and they figure out exponentially how much it's going to be worth. But of course, that's all relative because then if nobody cares about it, then it's not worth anything. Okay? So this is going to be your homework. I will make a separate video for that.